Okay, maybe it's better to give an example, right? So let me copy the finite difference code and goes to our lecture 11. And we are going to modify it to finite volume. So let's close this and name this as finite volume. All right. So when we have finite volume, the first thing is that our U0, which is going to be the initial condition for our solution, now means different things, right? It means different things because in finite volume, we no longer track the solution on the grid points. Instead, we track the average of the solution in between the grid points. So now let me define my x to go from 0 to n. Okay, so basically that includes both ends as opposed to only include, basically instead of excluding the rightmost point, which we know is actually the first point. So here we actually include both ends. And U0, if we want U to be a sinusoidal function, okay, then U0 is different. So U0 would be the integral of the sinusoidal function. And what is it? So let's actually work it out. So now let's go to an example. So let's say if U is a sine of 2 pi x, okay, what is my U bar? What is my U bar from, let's say, I delta x to I plus 1 delta x? Well, we can just follow the definition. The definition of an average is 1 over delta x, 1 over the length of the domain, integration from I delta x to I plus 1 delta x of this sine of 2 pi x dx, right? Okay, and this is basically 1 over delta x of, if you integrate a sine, you get a minus cosine, right? 2 pi x. And to make this integral, you have to multiply 2 pi into the delta x to complete the integral. So basically, you have 2 pi times delta x. So you have this integral integrated from I delta x to I plus 1 delta x. All right. Agreed? So that's going to be my initial condition. My initial condition has to be consistent with the definition of now the numbers I'm going to be using in my ODE, right? So let's actually plug this in. So my U0 is going to be cosine of 2 pi delta x. So let me just say this is U0 integral is going to be cosine of this, actually minus cosine of this, divided by 2 pi. Okay, so and my U0 is going to be U0 int 2 to n minus U0 int 1 to n minus 1. So that's basically taking this a difference between the I plus 1 times delta x from I delta x. Right? Okay, and let's actually plot it also in a different way. Let's plot it in a different way in the sense from x 1 to n minus 1, x 2 to n. So basically we are we are basically plotting the solution with short lines, and you're going to see this a little bit later. U0, U0. So let's actually make sure this works. I think, oh, I need to close. do this. Right, so I'm plotting this as a very short line. So it's actually a little bit better to see that using a smaller n. And let me just plot this as black. Okay. Oh, I think I forgot to divide by delta x. Right. So in my formula, I think I have to divide by 2 pi delta x. So I'm actually should be dividing by 2 pi delta x. And my x, of course, is equal to x2 minus x1. Delta x is equal to x2 minus x1. And let me close this and run the section again. So right, so this is actually going to be the volume averages of my initial condition, right? Basically, for every number in this U0, I'm plotting this number as a short horizontal line to indicate that this is actually an volume average. All right. Okay. So now, any questions?